Okay, here we go. Next lesson is actually called 11.6 out of the purple book, adding and subtracting the rational expressions. And here's your examples out of your packet. So when we're talking about rational expressions, really we're just talking about like fractions, because something that's rational is a ratio of two things. So all of these are ratios. So if you refer back to the basics of adding and subtracting fractions, you have to have a common denominator. So in this first kind of example that's up at the top, a over c plus b over c is equal to, you add the numerators, a plus b over the common denominator c. So we will not be adding the denominators. We are just making sure that we have a common denominator. So in example 1, 2 over the expression x plus 3 plus 5 over the expression x plus 3 could be simplified as 2 plus 5 over the expression x plus 3. This is the common denominator. So we can simplify the numerator, right? 2 plus 5 is 7. We cannot, however, simplify the denominator because it is an expression with a variable, and therefore here is our solution, 7 over x plus 3. Okay, so on the try it, anytime you'll have an expression in the numerator, you want to make sure that you have a like terms before you actually combine them. So we would have 3n plus 2n all over the common denominator of x plus 2. Since 3n and 2n are like terms, we can simplify them to 5n over x plus 2. Nothing that can be simplified, therefore we have our solution. Okay, so make sure that you either pause the video to write this down. I'm going to clear it so that I can scroll down, I think. All right, let's see what else we have. So in example 2, okay, example 2, we have just a little bit more detailed of denominators, but double check that the polynomial is exactly the same. So with subtraction, if they have the same denominator, you can go ahead and subtract the numerators. Subtract the numerators. So we'll have this 3n plus 4. Now what we're subtracting is an expression, so let's go ahead and write it in parentheses because we understand that subtraction has to apply to both terms in the expression. All right, all of that over the common denominator, 2n squared plus 5n minus 3. Now, when you have an expression after the subtraction, you have to understand that that applies to both terms. So it's kind of like we're distributing a -1 in a way. If I can kind of like make this look like a -1 and then distribute that here and distribute that here. So when I rewrite this numerator, I have 3n plus 4 minus 2n, and then a -1 times a -1 is a +1. All right. Now we want to combine some like terms. All right. Put that over. I'm looking at this and I think that I have another typo, but we'll see. Again, I apologize. So we'll work this out. We'll see how far we can get with this, and then I'll kind of explain what it would have been had we done it the correct way. All right. So the like terms here are going to be the 3n and the -3n. And then we also have a +4, and in this case a +1. So we would write this out, and then let's go ahead and factor the denominator to see what we got going on. Yeah, this isn't going to work, but we'll just do it anyway, and then I'll show you what the mistake would have been. Good old typing errors. All right, so 3n minus 2n is simply going to be n. 4 plus 1 is 5, so n plus 5. And then what we would do is look for, well, I guess we want to use a factor fish. If we use a factor fish to get the factors of the denominator, you're looking for, you have like this 2 and negative 3 that need to sum to a positive 5, right? So 1 and 2. And then the factors of 3 are going to be a negative 3. You'll have like a negative 1 and a positive 3. So when you get this going on, we'll have a negative 1, and we'll have a positive 6, and 6 minus 1 is a positive 5. So then we know we have like 2n minus 1 and n plus 3. So 2n minus 1, n plus 3. Okay? Now, looking at the numerator, n plus 5 as an expression does not cancel with n plus 3. It does not cancel with the 2n minus 1. So there's not much we can do here. Now, I'll show you. So this would be the final answer as this example is worked out. Okay? Here's where the mistake is. When I typed this up, this should have been, so let's look at it if we had a different scenario. Okay? So you can finish out this problem and say, okay, now it's done. And maybe on a separate sheet of paper, write a different problem. And let's look at what would happen if this were a plus 1. Okay, so I'm going to clear it out again, and I'm going to redo it with the plus 1. All right, so here we go. So now in a perfect world, this would have been plus 1. All right, so the common denominator, so we have 3n plus 4, and then minus, we have 2n plus 1. Okay, and all of that over this, we don't have to factor at this point. All right, now again, we're distributing to both parts, so we'll get 3n plus 4 minus 2n minus 1 all over our polynomial. Combining the like terms, remember, like terms, watch the signs. All right. Now we have the 3 minus the 2, we're still going to get n, and then 4 minus 1, now it's going to be 3, so n plus 3. Now we've already factored, remember, we factored the denominator, and we got two factors. We got 2n minus 1, and we got n plus 3. So that's something else that you're going to be looking for, is to see if you have anything that cancels. So whenever you have a trinomial, make sure you factor it out. Anytime you have something that can be factored out, make sure you're doing that to do this. So then you have your, don't forget the sound effects, right? So our final answer in this case, with this being a positive 1, that's the key difference to what's typed and what's corrected. This answer then becomes 1 over 2n minus 1. Okay. Let me double check. 7b minus 2 over 3b plus 6. You know, it's easy to correct when we're face-to-face and in a classroom. We just all erase it and correct our notes, you know, right then. So I apologize for that. Okay, so we have a common denominator of 3b plus 6. So we are going to take our 7b minus 2, and then since it's subtraction right here, you can see that subtraction, we are going to subtract this b plus 7 all over the singular 3b plus 6, okay? So if we distribute the negative inside these parentheses, 7b minus 2 minus b minus 7 all over 3b plus 6. All right, combining like terms, the 7b and the negative b, all right, and the negative 2 and the negative 7. So we'll have 7b minus b, which would give us 6b, negative 2 plus negative 7, minus 9, all over 3b plus 6. Now let's look at this, right? When you're looking at all of the coefficients and constants here, the 6, the 9, the 3, and the b, they all have a common factor of 3. So it seems logical that you could factor out a 3 in the numerator and factor out a 3 in the denominator. So if I factor out a 3 from the numerator, it's like 6b divided by 3, right? And I'll be left with 2b minus 3. And in the denominator, if I can factor out a 3, which I can, I'm left with b plus 2. It is only when you've factored it out, right, that you can divide it out, or you could probably, I guess, work with, this expression and say, okay, 6 divided by 3 is 2, and 9 divided by 3 is 3, and 3 divided by 3 is 1, and 6 divided by 3 is 2. Because these cancel out, and basically this is what we're left with as a solution, 2b minus 3 and b plus 2. So as long as you're able to cancel it out from every single coefficient or constant, then you can, simplify. But I like to factor it out and then cancel it out. All right. Again, pause so that you can get this copied down, because I'm going to clear it out. All right, next example, you'll have to turn over your page. Example 3. Now we're going to start looking at what's going to happen if we do not have a common denominator. All right, so we're going to have to find a common denominator. So if you remember, with regular fractions, right, what if there had been no variable, right? You're trying to get 2/3 plus 1/6. We know we have to use a common denominator of 6. Well, when we're looking at this, between the denominators, what you're finding when you find a common denominator is the lowest common denominator, okay? And one way I like to do that, I like to use this like upside down cake thing, and I say, okay, I've got 3x, and I've got a 6, and what can I factor out of both of those, right? I can factor out a 3. Great. What do I get left with? An x and a 2. And to find the LCD, or the LCD and the LCM are the same thing, I am multiplying all of these together, right? So 3 times x times 2 is going to be 6x. All right, so we want a common denominator of 6x. To get that, we rewrite it with a denominator of 6x. So my first thing to get, 3x times what equals 6x, I have to multiply my first fraction by 2 over 2, okay, fraction equal to 1, and then I'm going to get my second one just times the x over x, okay? So I'll rewrite these as 4 over 6x plus x over 6x. Now I'm adding 4 plus x over a common denominator of 6x. I would go ahead and say that's perfectly fine to do it that way. Big Ideas may want you to put it in standard form, so you may want to rearrange the numerator since they're both positive, over 6x, something like that. The reason we can't cancel between the 4 and the 6 is because x has a coefficient of 1. So you have to remember that you can only cancel or find something to factor out and simplify if, like, all three, 1, 2, and 3. So the 1, the 4, and the 6 would have to have a common factor. And since they don't, either of these are good. All right, so looking at 7y to the 4th and 3y squared. 7 and 3 both go into 21, right? That's probably the closest number that they both go into. Then when we're looking at the variables, since they both have variables and they both have a y, so you want it to be the one with the highest exponent. So I know that my LCD, my lowest common denominator, would be 21y to the 4th. If we want to test it out, we've got 7y to the 4th, and we've got 3y squared, and the only thing they have in common is 2 y's, right? The y to the squared. So we are left behind with 7y squared, and we're left behind with the 3, and again, you multiply all of these together, and that's how you get your 21y to the 4th. Okay, that's a y. Okay, So we're going to rewrite these with that. So to get 7y to the fourth, I'm only multiplying by 3. So I will take my 3 over 7y to the fourth times a fraction 3 over 3. I have my 2 over my 3y squared. Now, to get 21y to the fourth, I'm going to have to multiply by a factor of 7 and a y squared. So I'm 7y squared here that I'm multiplying by. Okay, so I rewrite them now. 3 times 3 is going to be 9 over 21y to the fourth plus 2 times the 7y squared is 14y squared over 1y to the fourth. So 9 plus 14y squared over 21y to the fourth. 9 does not have a factor of y. We cannot cancel or simplify any y's. The only thing we could do, right, we could say this is our answer, nothing to simplify, or we can change the numerator so that it is in more of a standard form with the variable first. Either of these, because they're both positive, would be acceptable. Okay, so there you go. All right, I'm going to give myself more room for example 4, which will be our final example for this lesson. So if you want to pause the video and write anything down or take a picture of something and ask me a question, whatever you need to do to get the help that you need. But I am going to be clearing it out, and here we go. Last one. All right. So this will work the same thing. You'll go through the same process if you're doing subtraction and you need to get a common denominator. The main thing is to rewrite each of those fractions with the common denominator. So now we're looking to see what is the common denominator between c plus 2 and c minus 2. More often than not, the thing it's going to be to multiply them together. So the common denominator would be c plus 2 times c minus 3. Therefore, to get that common denominator, we would have, because now they're expressions more than monomials, we would take the first one, 5 over c plus 2, and we're going to multiply times c minus 3 over c minus 3. Okay, that's going to be plus, and then to get the c plus 2 as a part of the denominator in the second ratio or fraction, we'll take 6 over our c minus 3, and we'll multiply the whole thing times the expression c plus 2. All right, so now we have 5 times c minus 3 all over this c plus 2, c minus 3, plus 6 times the c plus 2 all over, it doesn't matter the order of the fractions here, we can keep it the same, c plus 2, c minus 3. And then let's go ahead and distribute. Let's distribute here and here, here and here, so that we can get some like terms and things like that. So that's going to be equal to, I'll distribute and write it all over one denominator at the same time. How does that sound? 5c, and then we have 5 times negative 3 is negative 15. And then since it's plus, it's not going to change the sign of everything. Well, maybe I'll do it this way. Sorry. C plus 2, C minus 3. Just in case, I'll show it to you with all the work so that if you do have a subtraction, you would have it simplified first. So CC plus 12 all over our common denominator. Now we'll write it. 5c minus 15 plus 6c plus 12. This gets to be quite a lot of work, people. I don't know what I'm doing here. I don't know. And it is c plus 2, c minus 3. All right, like terms right here and right here box around the constants. So that'll give me, so when you have 5c and you subtract, this is a plus. Be careful, I put a box around that. So plus 6c. Plus 6c, make sure you know the signs between them, is going to give us 11c. The negative 15 and the positive 3 is minus 3. Okay, that whole thing is over your c plus 2, c minus 3. Now, we cannot cancel anything because 11 and 3 do not have anything in common for us to factor out. So we cannot simplify it further, and therefore this becomes the solution. All right. So looking at the next one, we'll multiply the denominators together when they're expressions to get the common denominator. So that means that we'll take the first one, negative 2 over the a plus 2, and we have to multiply it by 2a minus 1 over 2a minus 1. Add to that 3a over 2a minus 1 to get the common denominator, a plus 2 over, a plus 2. I meant for this to be one big parenthesis. Okay, that would simplify to a negative 2 times 2a minus 1 all over a plus 2 and 2a minus 1 plus 3a, a plus 2 over, and then I'll keep that factor first, a plus 2 over the 2a minus 1. All right, now we're ready to distribute. So I would get a negative 4a plus 2 over my a plus 2, 2a minus 1, plus I have my 3a squared now. Look at this, I've got a new term, 3a squared, and 3a plus 2 is 6a all over a plus 2, 2a minus 1. Now when I write this as 1, and I do my like terms, right, I've got this negative 4a and this positive 6a. The 3a squared is its own, and it's plus, right? And then this positive 2 has to be like a different shape or something because it's a constant. So I want to put it in the standard form. So I would obviously take my 3a squared first. Negative 4 plus 6 is going to be plus 2a, and then plus 2 all over a plus 2 and 2a minus 1. I mean, I guess we could try to see if there's anything to cancel. This is what I have as a solution. So, we can definitely, you could factor the numerator to see if in factored form there's something to cancel. But with very little inspection, you can see that it's not factorable because when you start to factor fish, there would not likely be any factors, combinations that would give you a positive 2 in the numerator. So this would be the simplest form, but you would definitely want to check to see if your numerator could factor and cancel out any of the factors in the denominator. We could also kind of look back here at like this step right here and see that, even though we do have a factor of a plus 2 and a 2a minus 1, there's no like that 3a minus 2, there's just no common factor there between all of it that we could factor out when we combined it in order to get our distributed it and then combined like terms. So yeah, this numerator is non-factorable the way that it is. All right, so that is the end of the notes for lesson 11.6. And if you have any questions, please be sure to email me, text me, sign up for the helpline, whatever it takes to get you what you need to understand.